So welcome students, welcome to the part 2 of the video matter around the sphere class 9. If you haven't watched the first part, you can watch it by clicking the link in the description or comment. So let's start the part 2 from solutions. So solutions are of three types: true solutions, suspension, colloids. So first understand true solutions. A solution is a homogeneous mixture of two or more pure substances. A solution is made up of two parts, that is solute and a solvent. Usually the component which is present in large amount is solvent and other is called solute. In case of solution of sugar and water, sugar is the solute and water is the solvent. uh, Example in case that is example. So aqueous solutions, a solution made by dissolving various solutes in water, are called aqueous solutions. So properties of solution, that is, a solution is homogeneous in nature. The solute particles in a solution easily pass through a filter paper, thus a true solution passes through a filter paper. Third, the solute particles in a solution cannot be seen by naked eyes, that is, they are microscopic. Fourth, the properties of a solute are retained in the true solution. Thus, a sugar solution is sweet in taste and the solution of salt in water is saline in taste, that is salty taste. And next is, a true solution does not scatter light and hence does not show tindal effect. In other words, solutions are transparent to light. Next, the solute particles in a solution do not settle on keeping. And the last one is, the diameter of solute particles in a solution is about 10 raised to minus 9 meter. So we talk about solutions, and now we talk about the types of solutions. That is a solution of solid in a solid, solution of solid in a solid, and solution of liquid in a liquid, and solution of gas in a liquid, solution of gas in a gas. So first talk about solution of solid in a solid. Metal alloys are the solution of solids in the solid. So keep in mind, solution of solid in a solid, uh, that is metal alloys. Example, brass. Brass is a solution of zinc in copper. Brass is prepared by mixing molten zinc with molten copper and cooling their mixture. So obviously you can see brass is solution zinc, that is zinc and copper, so both are solid, that is solution of solid in a solid. Next is solution of solid in a liquid. This is the most common type of solutions. Sugar solution and salt solution are the solution of solids in liquid. Although you know that sugar is a solid and salt is also solid, but it is in the very small size. So it is a common example of solution of solid in a liquid. A solution of iodine in alcohol called tincture of iodine is also a solid in liquid type of solution. This is because it contains a solid, that is iodine, dissolved in liquid alcohol solution. Next is solution of liquid in a liquid. So this is vinegar is a solution of acetic acid in water. So so both are liquids. Next is solution of gas in a liquid. Soda water is solution of carbon dioxide gas in water. Because you know that in soda water or any other cold drink there is presence of gas. So this is gas in a liquid. Next is solution of gas in a gas. Air is a solution of gases like oxygen, argon, carbon dioxide and water vapors, etc. in a nitrogen gas. So nitrogen is the solvent in air and all other gases are the solutes. So next type of solutions is suspensions. A suspension is a heterogeneous mixture in which the small particles of a solid are spread throughout a liquid without dissolving in it. So example, chalk water mixture, muddy water, milk of magnesia, sand particles suspended in water, and fluorine water. So clearly you can see the suspension is one, it is a heterogeneous mixture, and the material in the liquid cannot be dissolved. You can see the boundaries, separate boundaries. So the properties of suspension, let's see. First, a suspension is a heterogeneous mixture that we talk about. Second, the particles of a suspension do not pass through a filter paper, but it is in a true solution. But in the suspensions, they do not, the that paper cannot separate it. Third, the particles of suspension can be seen with naked eyes or with the help of simple microscope. Whereas in the that true solution, we only can see that particles under a high precision microscope. The next is fourth, the particles of suspension settle down when a suspension is left undisturbed, thus a suspension is unstable. Next is the size of particles in a suspension is greater than 100 nm in diameter, means 100 nanometer in diameter. And last thing is, a suspension is not transparent to light. Now let's talk about third type of solutions, that is colloids. A colloid is a kind of solution in which the size of solute particle is intermediate, that is medium in size, between those in true solution and those in suspension. The size of solute particles in a colloids is bigger than that of true solution but smaller than those of suspension. Dispersed particles. So solutes particles are also called dispersed particles. Dispersion medium solvents are also known as dispersion mediums. Solution, suspension and colloid differ in the size of solute particles, the size of particles being minimum in solutions and the maximum in suspensions. Now we talk about properties of colloidal solution. First is heterogeneous nature. A colloid solution is a heterogeneous in nature. It consists of two phases, that is dispersed phases and dispersion medium. Filterability. The size of colloidal particles is less than pores of a filter paper and therefore they easily pass through a filter paper. Colloidal particles, however, cannot pass through the parchment paper or an animal membrane or ultrafilter. Tyndall effect. When a strong beam of light is passed through a colloidal solution placed in dark place, the path of the beam gets illuminated by a bluish light. This phenomenon is called Tyndall effect. The phenomenon is due to scattering of light by the colloidal particles. So you can see that the Tyndall effect is only occur in the solution of colloids solution. The same phenomenon is noticed when a beam of sunlight enters the dark room. It is just like that, through a small slit due to scattering of light by dust particles in the air. Visibility. Colloidal particles are too small to be seen by naked eye. They, however, scatter light and become visible when viewed through an ultra microscope. Brownian movement. So you know what is a Brownian movement? Brownian movement is movement in any direction, in any, means there is too much, they can move freely. That is Brownian movement. When colloidal particles are seen under an ultra microscope, the particles are found to be in a constant motion in zigzag path in all possible directions. This zigzag motion of colloidal particles means they can go in any direction. Zigzag motion of colloidal particles is called Brownian movement. The movement of the particle is due to collisions with the molecules of the dispersion medium. Diffusion. Colloidal particles diffuse from a region of higher concentration to that of lower concentration. So obviously you learn this diffusion in the biology. However, because of their bigger sizes, colloidal particles move slowly and hence diffuse at slow rate. So you can see they diffuse from higher to lower concentration. Because of their big size, they cannot diffuse faster, the diffusion process is slow. Next is sedimentation or settling. Under the influence of gravity, the solute particles tend to settle down very slowly. This rate of settling down or sedimentation can be accelerated by the use of high speed centrifugage called ultracentrifugage. So you know that centrifugal settling means the particles come at the bottom of any container. Classification of colloids. So there is also classification of colloids. So colloids are classified according to the physical state of dispersed phase, that is solute and dispersion medium solvent. Most of the colloids can be classified in the following 7 groups. Sol, as well, that is sol. Sol is a colloid in which tiny solid particles are dispersed in a liquid medium. Example is ink, soap solution, starch solution, and most paints. Solid sol. Solid sol is a colloid in which solid particles are dispersed in a solid medium. Like example is colored gemstones like ruby glass. Next is aerosol. An aerosol is a colloid in which a solid or liquid dispersed in a gas. Means it can be either a solid or liquid in dispersed in a gas, that is including air. Example. The example of aerosols in which a solid is dispersed in a gas are smoke, which is soutenier, and automobile exhaust. So this is example for a solid, and the example of aerosols in which a liquid is dispersed in a gas are hair sprays, fog, mist, and clouds. Next is emulsion. Emulsion. An emulsion is a colloid in which minute droplets of one liquid are dispersed in another liquid which is not miscible with it. Example: milk, butter, face cream. Foam. Foam, in Hindi you say that jhag. The foam is a colloid in which a gas is dispersed in a liquid medium. Example: fire extinguisher foam, soap bubbles, shaving cream, and beer foam. Solid form. So the solid form is a colloid in which a gas is dispersed in solid medium. Example: insulating foam, rubber, sponge. So yes, gel. The gel is a semi-solid colloid in which there is continuous network of solid particles dispersed in a liquid. Example: jellies and gelatin. So these are all the colloids. If you have a problem that you have to learn all these things that are some emulsion, their definition, then it have very low chance of coming in exam. But you just focus on the examples, because you can ask in the exam that where is Tyndall facts done. So think about all these examples, learn them. Next topic is very, very important, that is differentiate between the true solution, colloid solution, and suspension. That is the difference in the solutions, types of solutions. So understand it. So here you can see the differentiate chart. Alright, now you can see the entire chart. You can take a screenshot if of this differentiate table. Alright, you can learn this. So next we talk about next topic, that is concentration of solution. Concentration of solution. The first is dilute solution. The solution having small amount of solute is said to have low concentration. It is known as dilute solution. Alright, the solution means having a small amount of solute, that is dilute solution. Next is concentrated solution. The solution having a large amount of solute is said to be of high concentration. It is known as concentrated solution. So you understand between both, that is small amount solute, dilute solution, large amount solute, that is concentrated solution. The concentration of a solution is the amount of solute present in a given quantity of solution. The most common way of expressing the concentration of a solution is the percentage method. Example, a 10% solution of common salt means that 10 grams of common salts are present in 100 grams of a solution. We can calculate the concentration of a solution in terms of mass percentage of solute by using the following formula. That is, concentration of solution is equal to mass of the solute upon mass of the solution into 100. The mass of the solution is equal to mass of the solute plus the mass of solvent, that is mass of solution, like you can see it, mass solution mass of solute will be added to the mass of solvent. So this is the mass of solution, entire solution. So we can obtain the mass of solution by adding the mass of solute and the mass of solvent. In the above given example, mass of solute is 10 gram and the mass of solvent, that is water, is 90 gram. So here you can see a well-known example. So mass of solution will be mass of solute plus mass of solvent. So we add both of them, we get the answer 100 gram. Now putting these values of mass of solute and mass of solution in the verb formula, we got concentration of solution, that is 10 upon 100 into 100, we get 10 percentage by mass. So the case of a liquid solute dissolved in a liquid solvent. In case of liquid solution dissolved in a liquid solvent, the concentration of a solution is defined as volume of solute in millimeter present in 100 millimeters of solution. For example, a 20% solution of alcohol means that 20 milliliters of alcohol are present in 100 milliliters of solution. So the concentration of solution will be is equal to volume of solute upon volume of solution into 100. Next topic is solubility. The maximum amount of solute which can be dissolved in 1 liter of solution at a specified temperature is known solubility of that solute in that solute, that is at that temperature. Effect of temperature and pressure on solubility. So we understand that what is solubility. Now what are the effects of temperature and pressure on solubility? First is the solubility of solids in liquid usually increasing the temperature and decreasing the temperature. Second, the solubility of solids in liquid remains unaffected by changes in pressure. Third, the solubility of gases in liquid usually decreases on increasing the temperature and increases on decreasing the temperature. Fourth, the solubility of gases in liquids increases on increasing the pressure and decreasing the pressure. And from physical and chemical changes we will do in the next part, third part. Bye bye. If this is really helpful, then please like and don't forget to subscribe so that you get the notification of the third part of this video. Bye bye.